Alright, question 4 looks at the opening problem. I don't know if we even went through that, but it's a fairly simple example where what you do is you cut squares out of a piece of paper, and what you want to try and do is make the biggest box that you can. Right, so what's the maximum capacity of that box? So really it's saying how big should these squares be in order to make that box. So if we cut out squares of x, alright, so the trick here is to actually be able to label these sides. So if we know that there is x, then we know this is going to be 297 take 2 lots of x, because you're taking x from either end, and then this side over here is going to be equal to 210 take 2 lots of x. You get the idea? Right, so part A says if we cut the squares out, find the length and the width of the box in terms of x. Alright, so that's what it's going to be. Probably worthwhile just doing a very quick sketch of your box, so you get a picture of what's going on with it. So our box is looking something like this. What's the height of the box? Well, we're cutting out squares of x, so it's going to be x there. It's going to be 297 take 2x there, and it's going to be 210 take 2x there. Alright, so that is the dimensions of my box. It says now find the capacity of box in terms of box C in terms of x. Well, we know the volume of this particular box is in fact going to be our height, or times by our base dimensions, which is going to be that. Alright, so nothing too tricky with that. And now it says you use technology to help sketch a graph to find the function's maximum. Alright, so obviously if I need to FOIL that out and all that sort of gear, now I don't know if I could be bothered doing that. So I'm just going to put that into the calculator as we see it there. So I'm going to say that's x bracket 210 take x, take 2x, bracket 297 take 2x. Right, bottom line is I'm just trying to find what x is, aren't I? So now if I graph that, what are we looking for? We're looking for a maximum, aren't we? The maximum volume. So can't see anything there in my graph. I'm probably going to change my window, maybe put an extra 0 on the end. And we'll see, and we might make that say 50 as well. We'll graph that, see if we can see part of our graph now. For that, nothing yet. So what I might do, I could probably just keep going, put another 0 on the end. Right, see if that finds me a point on that graph. Alright, so I'm getting closer. So you can just keep going up each time. Okay, so put another 0 there because I'm not to my max point. It tells you in the question what you've got to find. It's just a matter of finding it. So if I go graph now, oh, I'm getting closer. Oh, I'm not quite there, and put another 0 on the end. So that's one way of doing it. The other way I could have done is do my zoom fit and see what that gives me. Oh, I've gone too big now. But you can see I've got to my maximum point. Probably need to change that to be maybe a bit bigger as well, 100. And I'll not change that. That's big enough. I can see what I'm going to do. Alright, quite clear. You can see you've got your maximum point over here somewhere. So that's really what I'm interested in finding. So go to number 4 this time in your G count. So we're going to go left hand side. Let's go say 5. Enter. Remember I made that 100, so let's make that 90. That should be on the other side. Yeah, definitely is. And then I can find my maximum B. So my maximum is going to be quite a big number. Alright, so that's actually going to be 1,128,495 when x is equal to 40.42. Alright, so go back to here. It says yes, use technology to get a sketch of the graph. I'm going to make my graph look better than that. Alright, so I'm going to do x, I'm going to do my volume over here. And so remember we're working in centimetres. So I'm going to do something like that. try and make it symmetrical. 100 there, right? And then that's going to be, what was it, 10 million I think I had. Oh, don't probably do 10 million. If you did your graph for that, if you went something like 2 million, all right, would be probably a better way of doing that. So that would be, say, 2 million, and that would give you quite a big graph, wouldn't it? All right, so that's the value that we're looking at there. So that was 40.42? So that's the thing I'm looking for there. All right, and then we know that's say 1.128 where was that? 1.28495. Well, it's a bit easy if you've got your calculator sitting there. So 8,945. Right, so I know you can do that and get that value. So it's a massive number. And obviously that's in cubic centimeters, so when you convert that to litres, so that would be that's in millimeters, so that's actually about 1.1 litres. All right, so it's not a very big container in regards to that. If we go to the next bit over here, find the maximum capacity of the box and value of X that occurs at. So again, the process is just reading that off. I would like you, if you could say, is X is equal to 40.42 millimeters, and therefore the volume is equal to 1.1 litre. 1.2 litres. Alright, so that, or 1.3 litres, closer to that, isn't it? And showing that value, so that shows a bit of an understanding about units of measurement, and not that will be very hard for you guys, because I know you're very capable. So that's a pretty simple case in terms of looking at that. So you need to make sure that you get your units right. In that particular case, we're looking at some quite big units when we're working in millimetres. Pretty straightforward. Have a go at that one again by yourself if you're having trouble with that.